My name is Georg Hebel. I'm working for AUCOTEC. We are a software solution provider in this area. And our main software product for supporting that stuff is called Engineering Base. And this is what I want to talk about, how to develop systems now. Here? Here? Oh. That's the right slide. Okay, there are well-known methods how to develop a system. So normally it's about interdisciplinary approaches because you are realizing complex systems. Many people have to work together. You have to fulfill your requirements. You have to do that in time and budget, and you have to control the whole process. So, and during this process, you produce a lot of data, and at any time in the process, you want to have the control. Normally, you're doing that with the V model. I guess that's well known, starting with the requirements. At the end, the product should fulfill all these requirements you're defining. And the method is the V model. And during this process, you get a lot of documents. And for example, on the left-hand side, you see some papers which describe your requirements to the systems. You see maybe functional diagrams, functional overviews, what your system should fulfill. It's going over then to physical diagrams, how to implement this system in the physical world. And maybe later on you have also a 3D mock-up where you define maybe where your wiring in your plane or whatever systems you have are running. You have any kind of list data you want to manage. And during the time you get a lot of these documents and you have to store it somewhere. Normally you do it on a hard disk drive and you have your folders and organize these things there. But you still have just documents, and important for your process normally are the data behind these documents. So, and this is where our platform comes into the game, which organizes your data. So instead of storing it anywhere in the file system and have single artifacts, you have only one single source of truth of all your data. That means you organize it inside a database. And this database, in this case, is called Engineering Base, and you are able to structure your data in the way you find it again during your process. And Engineering Base, the main feature of it is, let's say, to keep all this in sync, to have all your views to the data every time and everywhere in sync. You have a single source of truth of everything, and if you make a change, it will be changed everywhere in every document. And this is the main message I have here. What's important for your system engineering processes, that you have the full control over your data. And this is what we are providing here. And let's assume at any time of the process you want to have additional views on the system. Maybe you make discussions with your colleagues how to implement things, or maybe you need documents for a later process step. And this can be done maybe by, we call it 2D harness diagram, what you see in the middle of the slide here, or any kind of wiring diagrams or overview diagrams. And this is what I want to show you next, how to generate this stuff with Engineering Base in a very efficient way. So, and therefore I will show you some short movies with our platform. This is the user interface of our platform. On the left-hand side, you see a structured tree of all your data. On the right-hand side, you see a view of graphics. So, and every object you have in your data, you can place in the graphics and can create any kind of diagram. And normally this is a manual process. You would draw some lines, but if you already have the data inside the system, inside the intelligent database, you can analyze this database. And you can let the system calculate which components in your view have to be connected and how. And this is what you're seeing here. Here you have a, let's say, a smart preview of your diagram you want to generate, and you have the possibility to adapt the layout with very smart functionality. You see this, these lines are moving when you move a component. And so you can make, in a smart way, a good layout for your perspective, for your aspect you want to visualize. And when you made all these adaptations here, then the system automatically creates a persistent drawing which is connected to the data model. That means at any time you then change the data model, you get also the view updated. So you can be sure that every time your system and your visualizations are up to date. And you see some details in the drawings about maybe about screening, about drillings, and so on. This is important for processes in your company normally. And what we have seen now is what we call wiring diagram. There can be a different aspect shown on the same data. Now you do not want to see all those details of each and every single wire. You want to have just a functional overview of your system. And this is what we're seeing next with the similar application. You get again your layout can adapt it, but now without all these details. So we only have the functional channels, let's say, between components, which show you which components have a functional relationship to each other. And again, you get a drawing which is persistent and communicating with the database. You see all the connectors and maybe splices you have in your system. Yeah, and at any time, maybe during a change process, you make changes and add some components to your system, and you may check if everything you want to display is still displayed on the drawing, and this you can do also in an automatic way here. This was the first thing about how to automatically create, for example, wiring diagrams or overview diagrams. Now let's come to another point, what you can do in an automated way. This is here, it's about multidisciplines working together. What you see here is an overview drawing, and based on rules you can calculate parts you need. So in this drawing you saw components with connectors, and now the electrical engineers want to communicate with the mechanical engineers. And this is what you see here. This is, in that case, it's the mechanical system Creo. We can do it with almost every system on the market, that we exchange data with the mechanical system. So now you see we have added a connector. We have defined the bundle between the existing harness parts and the new connector, and now we send this information back to engineering base to have it again back in your single source of truth then. So now we're back in engineering base, and there we import now the information from the 3D system. We have it fully under control because we have delta management. We have again smart functionality to make the layout. In this case, this is not a wiring diagram, but the 2D harness diagram. And with this sophisticated functionality, you now get the 3D model flattened to the 2D world. And as well in the data model, you get now all the information about where is a path and how long are the paths. The electrical engineer in the meantime maybe has created the wiring, maybe he has drawn a circuit diagram, and now this information will be linked together. You have the information from the 3D system, you have the information from the circuit diagram, everything in the data model, and now you have a view with both. You have the view with the flattened, we call topology, and we have as well the information about the wires which are connected between the connectors, and we see all the lengths information coming from the 3D system. Now we can additionally define protective material to the bundles, and therefore we have a diameter we have to fulfill, and we can check in the 3D world if there is any mechanical collision of that, and this will be displayed then also in an automated way. You will see it immediately that these bundles are now adapted. The diameter of the bundles is adapted. So at the end, you have a consistent model with information from the mechanical world and information from the electrical world. So to summarize it shortly, the benefits if you use engineering base for your system design, you have an efficient engineering process, you have high quality data, and everything is transparent what you're doing. You know who is doing what changed at any time, and you have a single source of truth of your data for any discipline and for any follow-up process. And this is the message I want to give you, and before closing I want to show you another short video which highlights what we from AUCOTEC can do for you if you do system engineering. Should be noise. Yeah, audio. Yeah, thank you for your attention, and I'm happy if you want to contact us if you do system engineering with us.